Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over an example on how to calculate the critical points. Um, don't forget to visit our website at mathgotserved.com for access to a wide variety of math tutorials ranging from algebra all the way to calculus. So the instructions for this example, we are to find all the x values of the critical points for the given function. So let's say we have the function f of x equals 5 minus x to the 1/3 times x minus 2 to the 2/3. Okay, so what's involved in finding the critical points? Critical points, also known as potential extremers, are the points where the derivative is either equal to 0 or non-existent. Okay, so if you want to find the critical points, you want to um, find where f prime of x is equal to 0 or f prime of x does not exist. Okay, we have f prime of x equal to 0 where you have horizontal tangent lines. So you have a horizontal tangent here. F prime of x does not exist when you have a cusp, a corner, or a discontinuity. All right? All right, so this function is continuous. So there might be a cusp or corner or both in the graph of this function. That will be determined when we're looking for where the function has an undefined derivative. Okay? All right, so let's go ahead and do it. First thing we're going to do is find the derivative of this function. Okay, so we want to look for f prime of x. So f prime of x is going to be the derivative of this entire expression right here, 5 minus x to the 1/3 times x minus 2 to the 2/3 prime. Now, what differentiation approach can we use to find the derivative of this function? You notice we have the product of two functions, so we have to use the product rule. So u v prime, using your product rule, is v u prime plus u v prime. All right, so in this problem, let's call u. U is going to be the first function. U is 5 minus x, and v, u is 5 minus x to the 1/3, and then v is x minus 2 to the 2/3. All right, so this entire piece right here, this is u, and this is v. Okay, so we're just using the product rule. Now, in finding the derivative of the two functions, we are going to have to apply the chain rule because they're composite functions. All right, so let's keep that in mind. U prime is going to be the derivative of the outer function, which is the cube root function. We're going to have apply the power rule there. We'll have 1/3 times 5 minus x to the 1/3 times, using the chain rule, the derivative of the inner function. The inner function is 5 minus x. The derivative of 5 is 0. And the derivative of negative x is -1. All right? And then v prime, applying the chain rule. Oh, made a mistake here. This is supposed to be -2/3. Using the power rule, I have to subtract 1 from the power. All right, and then v prime, we're going to have 2/3 times x to the x minus 2. You subtract 1 from the power, we have -1/3. And then if you find the derivative of the inner function, you get 1. Okay, so there's u prime, v, and v prime. So we're going to put everything together into this function here. So the derivative f prime of x is going to be vu prime. So v is x minus 2 to the 2/3. U prime is 1/3 times 5 minus x to the negative 2/3. That times negative 1. So this is vu prime plus uv prime. Okay, so let's see what we have here. U is the quantity 5 minus x to the 1/3. And then v prime is 2/3 times x minus 2 x minus 2 to the negative 1/3. All right, let's go ahead and simplify this just using properties of exponents. So we can write this as x minus 2 to the 2/3. This has a negative exponent, so we're going to go ahead and reciprocate that. There's a 3 down here too, so we have 3 times 5 minus x to the positive 2/3 using the reciprocal property of exponents. This minus, I can put it in front right here, okay? Plus, now I have 5 minus x to the 1/3. This 2, I can put it upstairs here, divided by 3. Then using the reciprocal property of exponents, this becomes x minus 2 to the positive 1/3. All right, so let's go ahead and combine these two fractions so we can easily determine where the derivative is 0 and when it does not exist, okay? So to do that, I'll simply find the LCD. The LCD here is simply 3 times 5 minus x to the 2/3 times x minus 2 to the 1/3. So that's the LCD. All right, so to make the denominators identical, there is a 3 on both sides, so leave that alone. I just need to, here I need to add on 5 minus x. I meant multiply. 5 minus x to the 2/3. Multiply that to the top and bottom. So we have identical denominators. And then over here, I just need to multiply x minus 2 to the 1/3, top and bottom, x minus 2 to the 1/3. Okay, now let's simplify that. In the numerator, we're going to have now, if you notice, these two exponents are identical, right? So when you're the bases are identical. So when you're multiplying two exponents with the same base, you add the powers, right? So this becomes negative x minus 2. 1/3 plus 2/3 is 3/3, which is just 1. All right, plus. Now these two bases are identical, so whenever you're multiplying exponents with the same base, you simply add the powers, right? So we have 5 minus x, 1/3 plus 2/3 is 3/3, which is just 1. Okay, remember the this property of exponents, a to the x times a to the y. What you learned in Algebra 1 is a to the x plus y. Okay, so that's what I did here when multiplying these two quantities and these two quantities here also. Now we have identical denominators, so we simply express them as 1. All right, so the LCD, as indicated earlier, is 3 times 5 minus x to the 2/3 times x minus 2 to the 1/3. Let's go ahead and simplify the numerator. If I distribute the negative to these two terms, I'll have negative x plus 2. And I distribute positive 2 to these two terms. In this quantity, I'll have plus 10 minus 2x. All right? And we have that divided by 3 times 5 minus x to the 2/3 times x minus 2 to the 1/3. Okay, now let's go ahead and simplify the numerator. If we simplify the numerator, we have negative 3x plus 12. That entire expression divided by, let's see, 3 times 5 minus x to the 2/3 times x minus 2 to the 1/3. If you notice, we can factor out 3 from the numerator, and then that gives us 3 times negative x plus 12. Oh, negative x plus 4. Because we factored out that 3 out of there, so we have a 4 right here. Okay, that divided by 3 times 5 minus x to the 2/3 times x minus 2 to the 1/3. And then these 3's divide out. And there goes your derivative. Okay, so f prime of x, after all the cosmetics, is negative x plus 4 divided by 5 minus x divided to the 2/3 times x minus 2 to the 1/3. All right, so now we're going to divvy this up into two parts. Let's find where f prime of x equals 0, where you have the horizontal tangent lines. Okay, so in order to find this, we'll simply set the entire expression that we just got to 0. Okay, set the entire expression to 0 times 5 over 5 minus x to the 2/3 times x minus 2 to the 1/3. And you can just cross multiply. Put this over 1. When you cross multiply, you have negative x plus 4 equals 0. You add x to both sides, you have x equals 4 as your first critical point. All right? Now, how else do we find our critical points? You have to find where the derivative does not exist. What makes this expression undefined? Well, when the denominator is equal to 0. Okay? So we simply take the denominator, 5 minus x to the 2/3 times x minus 2 to the 1/3, and set them equal to 0. All right, so that will tell me the x values that will cause our derivative to be undefined. So here we can use the zero product property. We'll have 5 minus x to the 2/3 equals 0, and x minus 2 to the 1/3 equals 0 also. Okay, let's solve this for x. You raise both sides to the 3/2 power, 3 over 2, 3 over 2, and that yields 5 minus x equals 0. Add x to both sides, x equals positive 5. That is another critical point because the derivative is undefined at this x value. Now here, to solve this for x, we simply raise both sides to the 3rd power. To the 3rd power, and that yields x minus 2 equals 0. And then add 2 to both sides, and then you have x equals positive 2. Okay, so those are your critical points. So let's go ahead and write it down. Critical points are x equals 2. The x values of the critical points. X equals 2, 4, and 5. X equals 2, 4, and 5. So that's that. Thanks so much for taking the time to watch this presentation. We really appreciate it. Feel free to subscribe to our channel for updates to other cool tutorials such as this. If you have any questions or would like to make any requests for calculus tutorials, feel free to include it in the comments section below. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day.